Engineer, write us a work, go to Rajesh. Right? Is anybody worse than him? Oh, there are people worse than him? So you have to be popular enough to know that you're not here. All right, so we already talked about sequence. Let's review a little bit about sequence. The sequence, you have to know there was two type of sequence. There was a recursive sequence. Usually never tested, but at least you need to be able to write out first few terms for recursive sequence. And you have to know when the sequences converge or diverge. If they are fluctuating between two numbers, so like 2 plus -1 to the n. If 2 plus -1 to the n is going to fluctuate in between 1 and 3. And that's diverge. That's a very easy to tell that diverge because you cannot go to infinite. It's not bounded by certain things. It just fluctuating between two things. And even it's bounded, it has to be either strictly increasing or strictly decreasing. If you have strictly increasing and it's bounded, then yes, you're going to get a finite answer. If strictly decreasing, if bounded below, then you are going to have a answer. Now, we talk about how do we test monotonic. There's two ways to test monotonic. Which two ways? Derivative to do number line test. What is the second way, which is a lot of people don't understand the second one. What? Yeah, the algebra way, which is plug in your next term compared to your first term. Are they always a true statement or are they false statement? If it's a true statement, then they, let's say it's a to the n plus 1 compared to a to the n. If it's a to the n plus 1 is always greater than n, then that function is always increasing. If it's less than, it's always decreasing. So that has to be always true. That means you have to solve the algebra equation. It had to be simplified. We also talk about L-Hopital rule. L-Hopital rule can help you determine are they increasing or decreasing? Or are they converge or diverge by taking derivative top and bottom? Also go back to Calc 1, divided by highest degree of the power. Do you remember that? Divided by highest degree of power and go to infinite. That's a very common thing to use. Those skills that you need to always have. You need to always have. And now let's go talk about Alvin's question. Alvin's question says, how about this one? Oh, I think it's question 59. I think Alvin says, hey, how about this question? Right? 3 to the n to the 4 to the n. Now, L-Hopital rule does not work. L-Hopital rule does not work because you're going to get ln of 3, 3 to the x. ln 4 to the 4 to the x. Now you say, wait.
Should now be back A1.
I can really divide it by highest degree of the denominator. I mean, you can divide by 4 to the n, but you're going to get same exact. You divide top and bottom by 4 to the n, you're going to get exact same situation. So ideally, there is no algebra way to really prove that this is going to be converge. So 12, and like in this case, you just have to know that 4 to the n is going faster than 3 to the n. There's nothing else that you can do anymore, except today we're gonna learn a new skill. Exponent rule. How do you do exponent rules? Yeah. So yes, that's the geometrics. So 3 to the 4 to the n. You can rewrite it to this way. And you're like, well, how's this way? This way is gonna be easy, but then that require you to know something else that you need to know today. So we're gonna talk about series today. But if let's go to infinite, what will happen? If 3 over 4 to the n to the infinite, it's gonna be what? It's always gonna go 0. Why is that? Because you can do 0.9 times 0.9 times 0.9 times 0.9 times 0. Long as that is less than 1, then you'll eventually go to 0, because you're going to take 90% of each time and you're going to multiply multiple infinite amount of time. Eventually that's going to go to 0. So what this is actually a good way to think about, but why is this helpful today? Because today we're going to talk about series rather than sequence. So what is the difference between series versus sequence? So if I write down summation, this is going to be series, n equal to 1 to infinite of a to the n. So instead of sequence, just a to the n is equal to, a1, comma, a2, comma, a3, comma, a4. Now this time, this is going to be sequence if you have a to the n. If you have something like this, right? N equal to 1 to the infinite, so it's going to be a1, a2, a3, a4. This one's equal to a1 plus a2 plus a3 plus a4, and dot, 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 keep on going to infinite amount of pieces. So in this case, we're going to call it infinite series, because it go to infinite. And a1, a2, a3 are the term of the series. Is that okay? Now, if I want to say find a sum of a partial sum, sequence of partial sum. So if I say today is the sequence of partial sum, for example, like S1, S1 just means A1. Is that okay? S2 is going to be A1 plus A2. S3 is just going to be A1 plus A2 plus A3. So this is the partial sum of the first 3 terms. And obviously, of course, S to the n is going to be A1 plus A2 plus A3 plus dot, 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 dot to A to the n. So we call it n-term partial sum. But the other one is all partial sum. Now, if I have a n-term partial sum, like write out like this, Sn equal to a1 plus a2 plus a3 dot, 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 even to a to the n. If the partial sum it's converged, if it's a sequence of partial sum converge to S, then if Sn converge to S. That means you go to infinite, get to S. Therefore, S is the infinite sum. So sum of all the terms are adding together.
If it adds up to a number.
Yeah, then it's converge. Therefore, converge. Now, if you add up to be a infinite,
That doesn't really
it's
mean
converge to S, to a certain number. Let's say converge to 1/2. For example, if we eat 1/2 a pizza of 1/2 of 1/2 a pizza of 1/2 of 1/2 a
it
pizza.
converges to 0, basically.
No, it converged to a number. In this case, it converged to what? 1. Right? So if it's converged to a number, then you are converged.
Well,
A number S.
well, I should hope so.
But you can also not converge to, you can be like infinite. So you end up all the adding terms. So for example, 1 plus 2 plus 3 plus 4 plus 5 plus 6. What are you going to get? You're going to go to infinity, right? And the infinity is, in that case, that's called diverge. If the Sn diverge, then the series diverge. Series diverge.
But also, so, what does but saying therefore converge?
Yeah. So if
Series converges.
a series converge to S, if a series converge to S, so for example, you guys have to let me explain. If series converge to S, therefore that S is going to be a finite number, right? If it's a finite number, then the series converge. It's converged to a certain number. Now, if it's convert, if it go into, like say 1 plus 2 plus 3 plus 4, all the way to infinite, it's going to add up to be infinite. Then the series diverge. It's not, don't overcomplicate it, because maybe my words come out of my mouth is not perfectly sound. But just if you add up all the number, you don't get to a finite number, therefore it's diverge. If you add up all the number to infinity, then it's going to be converged to a certain value, then the series converge. That's it. So we call it the sum of the series. This is the sum of the series. It's not partial sum because it's not stopping at a term. So it's going to add up to infinite amount of terms. So we call it sum of series. If it's converged to this value, then it's converge. If it's go to infinite, it's diverge. Yes.
When they sum the series, the sum of infinite series.
Yeah, it's the sum of everything. Yes.
And then if it's Sn, then you know it's the partial sum.
Yeah, we're probably gonna stop somewhere. But if n goes to infinite, then that's gonna be an S. So I'm gonna give you a notation here. S is equal to summation of n equal to 1 to the infinity of a to the n. That basically you want to add up every single term to infinite. Now, if Sn diverge, then the series diverge. So there's two types of series that we want to look at it today. There was a type of series is, if we know, it's a geometric series and a telescope series. So let's just say if today you have this situation, it says n equal to 1 to infinity of 1 over 2 to the n. We're going to write our first few terms to show you what happens. So it'll be 1/2 plus 1/4 plus 1/8 plus 1 over 16. And then we keep on going to as many as we can, because here is infinite. We know that's end up to be what?
It's 2, right? Or, sorry, 1.
It's 1 or 2. It's 1. Think about it. If you have a pizza, right? and you eat half the pizza first day, so that's 1/2, right? And then you eat another 1/4 of pizza, that's the second day. And the third day you're gonna eat 1/8 of pizza, so that's gonna be 1/8 of pizza right here. Does that make you hungry? And then 1/8 of pizza, and then 1/16 of pizza. But if I keep on eating half of it each time, eventually it's only gonna get to maximum is one pizza as a whole. Are you? What do you mean I need to repeat that? Okay, let's just say for Shiv, or for you probably had to be 2 pizza.
Exactly.
Because you eat a lot of shit. Huh? I know. You're very kind. You always share your food. Okay, so if you keep on eating half of the pizza of the day before, eventually you can only get the maximum of 1 pizza. That's it. You're not gonna eat more because it's gonna be you take whatever half. You can even eat 3/4 of pizza each time. Now it's gonna give you certain things. So 3/4 of whatever left over. Now there's something that we can tell from doing all this is known as something called a geometric series. But we're gonna get to that later. But this situation is eventually we're gonna say that's eventually is equal to 1. We're gonna show you the formula afterwards. There was a second type of series. So this will be known as a geometric series.
Is it convergence or?
We're gonna talk about that in a second. Just give me a second. We're gonna show you second type though, and then we're gonna go back and review the first type. Is that okay? We're gonna go back. We're gonna come back to this, right? So what about this kind of series? This kind of series is actually interesting. It's a 1/n minus 1/n plus 1. Now this one is not tested often on AP exam, but this is called a telescope series. A telescope series. You're like, what is telescope? The best way is always plug in few number. Use a numerical approach. You're gonna see the pattern. So imagine if I plug in 1, so it'll be 1 minus what? 1/2, right? And we're gonna add to the next term. When n is equal to 2, what will happen? 1/2 minus 1/3, and then you're gonna be plus what? Sorry, not plus. So it's gonna be what? 1/3 minus 1/4, and then plus 1/4 minus 1/5, right? And dot. Would you say? What do you see? This and this cancel out.
So 1 minus 1/3. No. Oh, it's just 1.
This and this cancel out. This and this cancel out. Right? And even 1/5 will cancel out. So this term is going to get smaller and smaller and smaller. So can I write this term as Sn equal to 1 minus 1 over n plus 1?
Which is just 1 over 10. I mean, 1. Yes.
What happened when n approach infinity? So would a summation of this eventually is equal to 1? So summation of this eventually equal to 1, because you're gonna adding all the term in the middle. It's gonna slowly cancel out the term prior, cancel out prior. It's gonna cancel each term until you're gonna be always minus 1 over n plus 1, but n is gonna go to infinite. Imagine this n is gonna go to infinity. What happened when n go to infinity? That's just gonna be very, very small value. You're gonna adding smaller and smaller and smaller and smaller. Each term I'm going is gonna become smaller. So eventually this term is gonna become obsolete. This is the only answer left, it's 1. Which is this only answer here is gonna be 1 here. Sorry, let me go back. That's equal to 1. Oops, my bad. This one is only equal to 1. That's the only term left. Does that make sense? That's called telescope. Now, one last thing that I would like to show you. If you have m equal to 1, the infinite of 1, what do you think this one will end up to be?
Infinity.
Which is what? Diverge. Yeah, because it's just basically 1 plus 1 plus 1 plus 1. Even if it goes very, very slowly, this still gonna go to diverge. So in this case, this is diverge. So this is series diverge. Infinite series diverge. I mean, you can have a partial sum. You can have first 3 term would be 3. You have first 6 term would be 6. But if it goes to infinite, this is gonna go diverge. Yeah.
With this series, do you still have like certain series that increase faster than others, or something with the
Well, you're adding number. Later on, we're gonna talk about n-term divergent test. But we don't. Wait, can you rephrase that question again?
like if we still have like certain series that would increase faster slower than others. Like this one you're adding 1, whereas the other ones are like 1, 2, 3.
I think to answer your question properly, is a series doesn't matter which one go faster, but it does matter what happened at n, or all the thing you're adding together is gonna be a finite. Rather compare of two sequence. Sequences they can go to infinite, but some sequence is gonna go finite number. But we will, if you have numerator and denominator, you are comparing which one's gonna go faster. In this case, there's no numerator and denominator in this case. It's just pretty much all the middle terms going to go to 0. But this term eventually is going to go to 0 as well. So that's why there's a finite number. So we are not, I won't say you're not comparing. The only time is as a fraction. You compare which one's faster and which one's slower. Now, you do have to do that with the n divergent test. And that situation we're going to show you in another way. But right now, just let's look at it, you know, for right now, just look at us, are they going to go to a finite number or not? So what if I have a sequence like this? Now, sorry, this one is going to be 4 n squared minus 1. Now, what happened with telescope, right? Why does a telescope matter? Because telescope, you can always change into, for example, on the last case, is 2 fractions. And if they are subtracting each other and you have certain pattern, they will lead to.
Students for B1.
That's mine. I'm gonna go eat.
Probably $35 to watch.
We have to get a meeting to, I don't know, someone tomorrow. And then we have to get all the volunteer there to help out arrange a table Friday after.
Oh. That is not a full on.
Why can't we do it at lunch?
What's the announcement?
But let's put it at the table.
Um,
All of the other people know.
Yeah, I mean, even my after school tutoring kids
Yeah.
probably can.
we don't really need a.
All right, let's go take a look.
Yeah, oh my god, you do this, because I on my folder, I know, but I did it.
It's literally so much better to see you than like every time I like crazy.
I sit there too, I'm like,
so bad.
okay, I'll help you with the question. No, they were literally like, I was like, oh my god, I think like I really hurt my neck doing it because morning I was like, I feel like I was like turning in my bed and like I really hurt my neck. Like, oh my gosh, oh my god. And there's this one part where I'm like, oh. Anyway, I'll help you with the question. Yes, of course. Are you saying?
No, I'm not. English.
Yeah, y'all can share that great hair. If it was chocolate,
Not over.
I had one.
Oh. You're good with Swiss, right?
Yeah. Okay.
Here.
Are y'all doing?
What an arrowhead if it's like stretch.
Bro, Nate used to get it together, right? This is his phone.
I think so. Why did it explode hard? No, leave it here because he's gonna come back.
I know he's there.
Oh, you know you already said.
was the first to figure out how it was being done.
A very unlikely character, a trader at the Royal Bank of Canada, a young Canadian man named Brad Katsuyama, realized that the market that he thought he knew had changed. The market seemed to be willing to sell stock, but the minute he went to buy it, someone else bought it. The stock went up. It was as if someone knew what he was doing before he did it.
Back in 2008, Katsuyama was 30 years old and running the Royal Bank of Canada's stock desk in New York with 25 traders working for him. Every time one of them tried to buy a large block of stock for a client, their order would only be partially filled and the price of the stock would go up. It kept happening over and over again.
The best analogy, I think, is that your family wants to go to a concert. You go into StubHub, there's 4 tickets all next to each other for $20 each. You put in order, buy 4 tickets, $20 each. And it says you bought 2 tickets at $20 each, and you go back and those same 2 seats that are sitting there have now gone up to $25.
What did you think the problem was?
I had no idea. I couldn't get answers.
At first, Katsuyama thought it must be that the technology at RBC was slow, until he went to Stamford, Connecticut and paid a visit to one of the largest hedge funds in the world.
The same things that I was experiencing as a trader, one of the most sophisticated hedge funds in the world was also having the same problem. Then the light bulb goes off, you say, holy cow, this is a huge problem.
You were determined to get to the bottom of it.
Yeah,
Why?
because it just didn't feel right. It didn't feel right that people who are investing on behalf of pension funds and retirement funds are getting bait and switched every single day in the market.
Katsuyama suspected that the problem had something to do with plumbing, the way the trades were routed through fiber optic cables from his trading desk in Lower Manhattan to the 13 public exchanges in northern New Jersey. But no one would tell him exactly what happened to his orders once he hit the buy or sell button. So he put together a team of technical experts, traders, and most importantly, an Irish telecom guy.
Students, 1 minute remaining until class.
Where you been? Where you been? All right, get your homework out. You should be looking at your homework. Where's the Armin?
Oh, you got the freaking water.
Browsing, and then they come back to the car. It's the exact same.
My homework, sir. Where's the homework?
Okay.
Use the meter so you can measure the But if I write,
Yeah, I didn't. I got a different. Oh, okay.
Yeah, most of these I just we don't really have here. Remember?
Or it's 0.25. Don't take it over yourself. Like in the two's on the top.
multiply by 1. Yeah. Oh, I will. Yeah.
Oh, my God. It's like margarita.
All right, so shh. All right, so there are 3 people I'm concerning about. One's Alan, Ethan, and Liam. Balin just not here for a whole week, so I understand that I'm not get it done. But I don't know, like, I don't know what to tell you. This is the 4th quarter. No, for me, it's a 4th quarter. This is the moment that you should be locked in for the whole every day. until end of the year in order to have a shot to pass the AP exam. But some of you guys are not doing that. The one of the major concerns Liam. So Alan, you need a better job, but I mean, I don't know what to say. It's just like, I finally got like a Nizar doing homework again, and Nizar asking question, which is good. He asked a great question yesterday, the day before, a bit help you with answering your questions. That's good. That's why I need to see is that people just, hey, I don't know if I'm doing this right. Can somebody help me fix it? That's fine. You know, there are a lot of things that you guys need to fix, as far as where the parentheses, which rule you should be using, which chain rule you be using, or product rule, or quotient rule. Every those rule are fair game. You gotta practice to have that muscle